Okay, as we go through today's class, we're going to make sure we're keeping in mind our chapter question of how can we gather more evidence about whether lava or water formed the channel on Mars. So that should be kind of in the back of our head as we go through everything, because ultimately we're trying to connect what we do to our channel that we're looking at on Mars and seeing how we can find that evidence. So the two questions we should be trying to answer today are, why do scientists use and rely on scientific models? And how is studying a landform helpful to geologists? So the questions you already answered was, first one, which of these questions would a scientist use a model to try and answer? You should have selected A, how this lake was formed. For the temperature of the lake, all you have to do is use a thermometer or a tool to measure the temperature. What is the rock at the bottom of this lake made of? We could go get that rock and actually test its composition and see what it is made of. And what types of fish live in this lake? We can observe the lake and try and record all the types of fish. We don't need a model for any of those. However, to see how the lake was actually formed, we would need to set up a model which shows us over a very long period of time what happened in that area to form that lake. That is why you should use that, because a model is something that is going to actually show something that we could not easily observe, whether it's too small or too big or something that happened over a really long period of time. A model is going to better help a scientist understand what happened during that time. So a lake would be a good example of a time over something that is too large and formed over a really long period of time. So using a model would be really helpful. So our key concept that we're going to make sure we are focusing on today is that scientists can use models to test their ideas and get evidence about processes in the natural world that are difficult to observe. A really good example of this was yesterday's article about that scientist, Guerra. And Guerra actually was able to observe Venus, and he saw some pictures of landforms over Venus, but wasn't able to study them much further. The conditions on Venus were too harsh to even land a spacecraft for a long period of time. So he needed to figure out a way to create a model of the planet Venus. Instead of making an actual physical model, what he did was use a computer model, basically a computer simulation, where he took something that was kind of like Earth and instead changed some of the features of that planet, like the temperature of the surface, the temperature of the air, as well as the thickness of the top layer of rock. He made it a lot thinner because he had a prediction that the top layer of rock on Venus might be thinner than that of Earth. What he then was able to do is press play on his simulation. And instead of this taking millions of years, he was able to see it in a much shorter amount of time, where he could tell what happened if that was the conditions on the planet that he predicted. As he played that model, he saw that on his simulation of Venus, his model of Venus, with those conditions that he predicted, he got the exact same landform that he was able to see in pictures from the actual planet. So that dome-shaped landform with cracks going from the middle and all the way outwards. So he was able to actually confirm his predictions of what created that landform on Venus that we can't create on Earth by looking at a computer simulation. If you're in cohort 1 through 4, you're going to stop right here and we're going to pick up the rest in class. If you're on cohort 5 through 9, you can go on to the next video, which is going to actually show you a physical model instead of a computer model about how landforms can be formed.